Hey everyone, today we're going to solve rational expressions. We're going to do it algebraically, and then we're going to apply it to word problems at the end. So, you just took a quiz over adding, subtracting, multiplying, and dividing with rational functions. Each time we did that, we got an excluded value to see what we could not plug in into our denominator to make it 0 because we can't divide by 0. This is when that number is going to matter, okay? So solving equations, we're going to treat it the same way as adding and subtracting, meaning my denominators have to be the same. Then we're going to solve for x. We got to make sure that that x is not part of one of my excluded values. Okay. So step one is always to factor if you can. For this problem, there's no factoring that I can do, but I'm going to go ahead and list my excluded values. So I see here I have x minus 3, x minus 3. So of all the values I can have, I can't have a positive 3, okay, because 3 minus 3 is 0. So that's the only value that's not going to work for me after I work it out, okay? Now let's work it out and solve for x. So my denominators are x minus 3 and 4. Well, some of them have the x minus 3, some of them have the 4, so they're missing the other half. So this first one is missing the 4, so I got to multiply all of this by 4. My middle piece is missing the x minus 3. I'm going to write this differently so you can see it better. So this one's missing the 4. There we go. My middle piece is missing the x minus 3. So we're going to bring that to both pieces. X minus 3. Here we go, x minus 3. And then my last piece, my denominator, is just missing the 4. So this needs to get multiplied by 4. This needs to get multiplied by 4. So now all of my denominators have a 4 and they have an x minus 3. What's nice with solving is that once the denominators match, I don't need the denominators anymore. They're gone. They've done their duty. We throw them away. Don't need them anymore. Now what we do is we simplify and solve for x in my numerator to finish our problem. So my first one I'm going to simplify is 4 times x plus 1. Well, 4 times x is 4x. And 4 times 1 is positive 4. In the middle, we have positive x times x, which is going to be a positive x squared. And I have a positive x times negative 3, which is going to be negative 3x. Now I have my equal sign, and on the other side of it, we have 4 times 4, which is 16. I see I have a quadratic now. We have an x squared. So what we're going to do is we're going to make the whole thing equal to 0, get it in standard form, and then we're going to factor. So I'm going to put my x squared first. That's my leading term. 4x minus 3x leaves me with a positive 1x. And then I do have this plus 4 right here, but if I bring 16 over, I have to subtract it, right? So 4 minus 16, to bring this over to this side, is going to give me negative 12. All right. Now we're going to solve. So I think what multiplies to give me negative 12, what's going to add to give me a positive 1, and that is going to be positive 4 and negative 3. Make each equal to 0 and solve. In this case, I'm going to get x equals negative 4, and I have x equals 3. Now, before I circle anything, I got to double check with my excluded values. Look right there, x can't be 3. So that in the very beginning. So because x can't be 3, that is not an answer. My only answer for this problem is going to be negative 4. Okay, and you can actually plug that in and check. Okay, negative 4 plus 1 is what? You have to plug it into the whole thing. Ignore me. All right. All right, so again, you can always check your answers by taking them and plugging them in. Do plug them into all the different x's, not just your numerator like I just tried to do. Plug it into your complete original equation to make sure that it does work out. All right, we're going to do another one. This one I have 3 over x minus 5 minus 1 over x squared minus 7x plus 10 equals 5 over x squared minus 7x plus 10. Now this is a minus, so just like last time, I'm going to distribute this minus sign up here to the 1 and make it into a plus. So that's first for this one. Now I'm going to factor my denominators. These are both the same thing, so they'll factor the same thing. Multiplies to give you 10, adds to give you negative 7. That'll be negative 5 and negative 2. Like this. Okay. So excluded value is going to go ahead and list it before I move forward. My x cannot equal. I cannot have positive 5. I cannot have a positive 2. That would make any of these parentheses a 0, and I can't divide by 0. Okay. Now I also notice that they all have an x minus 5, but my very first rational expression does not have the x minus 2 part. So we're going to bring that to this first expression, x minus 2. Again, once my denominators are the same, which they are now, I don't need them anymore. They've done their job. Now I'm going to focus on just the numerator. I'm going to simplify this piece. 3 times x is 3x. 3 times negative 2 is negative 6. Add negative 1, which means minus 1, and then equals to 5. Negative 6 minus 1 is going to be negative 7. Add that 7 to the other side, and we get 12. Divide both sides by 3, and we get 4. That was not in my excluded value, so that is going to be our answer for this one.
All right, so let's do one on your own. Okay, so we have 9 over x squared minus 2x minus 3 minus 2 over x plus 1 equals x over x squared minus 2x minus 3. So, yes. So pause, try it on your own, and then when you're ready, push play and come back and check your work. All right, check your answer with mine. You should have gotten x is equal to 5, which was not listed in my excluded values, so it is my answer. I can plug it back in and check. So, check it. Don't forget you have to distribute that negative to that 2 first, okay? All right, so that's solving. Now we're going to get into our word problems, which is directly correlated to it, okay? I know you usually hate word problems, but I promise you, you're going to like these, okay? Because they're worked out the same way every time. That's going to help you. All right, working alone, it takes May 10 hours to pick 40 bushels of apples. Eduardo can pick the same amount in 14 hours. How long would it take them if they worked together? Okay, so we're going to represent these as rationals, okay? So we have May. May is doing her job in 10 hours. And then Eduardo is doing that same job in 14 hours and wants to know what would it be to work together. So if I add their jobs together, how long would it take them together? So let's think about it. I'm not going to do 10 plus 14, right? I'm not going to average it out 10 plus 14 to get 12. But when they work together, they should be faster, right? It should be less than 10 hours when they work together, okay? This is all being compared to the same job of the apples. So when I create this rational expression, I'm going to make it 1 over 10 plus 1 over 14 equals 1 over x. They're all doing the same one job. Okay? They're making a ratio of the job over the hours it takes. Okay? Now, just like before, we're going to bring in the missing denominators. I have 10, I have 14, I have x. So this first piece is missing the 14 and the x. So I'm going to multiply it by, I'm going to multiply it by 14 and x. All right, over here, we're missing the 10 and the x. So we're going to multiply this by 10 and x. And then on the very end, we already have the x. We're missing the 10 and the 14, the 10 and the 14. Just like solving, denominators are now gone. I don't need them. They all have the 10, the 14, and the x. Let's simplify my numerators. So 1 times 14 times x is just going to be 14x. 1 times 10 times x is going to give me a positive 10x. And then 1 times 10 times 14 is going to give me 140. Right? Now we just solve for x. 14 plus 10, this gives me 24x. And then we divide both sides by 24. Get my calculator. Oh, it's right here. 140 divided by 24. I get about 5.83. So together, it takes 5.83 hours. Okay. This does make sense. When you find your answer, it should be somewhere in between half of both of the original. Okay. Half of 10 is 5, half of 14 is 7. I expected it to be in between 5 and 7, and it was 5.83. Because working together almost cuts your time in half. Granted, one of them is slower than the other, so it can't be completely in half. Okay, so you can kind of predict where your answer is going to fall before you actually start solving it. Let's do another one. We have working alone. Scott can paint a fence in 10 hours. So Scott's ratio is the one job in 10 hours. James can also do it in 9 hours. So he's doing the same one job in 9 hours. Find how long it would take to work together. So if they get together, how long is it going to take them? So again, like last time, half of 10 is 5, half of 9 is 4.5. My answer should be in between 4.5 and 5. Okay, let's see if my theory is true. So my first one, we already have the 10. We're missing the 9 and the x. My middle one is missing the 10 and the x. And my last one is missing the 10 and the 9. So this is going to give me 9x plus 10x is going to equal 90. I add these together to give myself 19x equals 90. Divide both sides by 19. Let's see here, 90 divided by 19. Look at that, 4.73. And that is in between 4.5 and 5, so I did predict correctly. So together, I'm going to type. Together, it will take 4.7, I'll say 4 hours to paint the fence. There we go. So word problems get their word answers. All right. It is time for you to try one of these. So let me show it to you. All right, we have Matt can wash and detail his truck for 3 hours, in 3 hours, excuse me. Jody can wash and detail the same truck in 5 hours. So how long would it take if they worked together? So I want you to pause, set it up, and solve it, and come back and see if you got the right answer. Go ahead and pause. All right, so in the beginning, you could kind of predict what was going to happen. Half of 3 is 1.5. Half of 5 is 2.5. So it's going to be somewhere in between 1.5 and 2.5. We had to multiply what was missing. So we get 5x plus 3x equals 15, which ends up being 15 divided by 8. So together, it's going to take them 1.875 hours to wash and detail the truck. All right. This is one type of word problem we're going to have. I'm going to show you the other kind of word problem you're going to get. We'll do 2 of those together and then do one on your own. So here, Ted can harvest a field for 10 hours. One day his friend Shanice helped him and it only took 5.24 hours. How long would it take Shanice to do it alone? So here, they've given me different information. I know Ted can do it in 10 hours.
I know together they can do it in 5.24 hours, but I don't know how long it's going to take Shanice by herself. So my x has moved into a different spot of my equation. Okay, we still solve it the same way I was solving the other ones. So my denominators are 10, x, and 5.24. But this already has the 10. We're missing the x and the 5.24. This has the x. We need the 10 and the 5.24. This already has the 5.24. We need the 10 and the x. So this first piece becomes 5.24x. This becomes 1 times 10 times 5.24 is going to be 52.4 equal to 10x. All right, to solve for x this time, I'm going to subtract over my 5.24. I'm left with 52.4 is equal to, let me do that over here, 10 minus 5.24, 4.76x. And then we're going to divide both sides by that 4.76. So 52.4 divided by 4.76 gives me exactly 11 hours. So Shanice can harvest a field in alone in 11 hours. Move that up here. Can't really see it, can you? There we go. Okay, so it's the same type of word problem. Okay, my x is just in a different spot. Okay, so let's do one more together, and then I'm going to have you try one of these by yourself. All right, working together, Perry and Kristen can tar a roof in 5.83 hours. Had she done it alone, it would have taken Kristen 14 hours. Find how long it would take Perry to do it alone. Okay, so it already told me together, right? So together it's 5.83. Kristen alone was 14 hours. We don't know how long it would be for Perry. Okay, it doesn't matter where I put the 1 over 6 or the 1 plus 14. I could have put the 1 over 14 plus 1 over 6. That order does not matter. All right, let's bring in my missing pieces. This first one it has the x. It needs the 14 and the 5.83. This needs the x and the 5.83. This needs the x and the 14. So let's start simplifying. 14 times 5.83. This is going to get me 81.62. Plus, this gives me 5.83x. This gives me equals to 14x. I'm going to subtract 5.83 from 14. So now I have 81.62 is equal to 8.17x. Now I'm going to divide 81.62 by 8.17. And I have 9.99, so I am going to round that to about 10. So alone, it would take, I can't spell, apparently. There we go. It would take Perry 10 hours to tar a roof. That's an interesting job. There we go. All right, there's one more. Working together, Matt and Jody can clean the house in 6 hours. If Jody works alone, she can clean the house in 10 hours. Find how long it would take Matt to clean the house by himself. So I want you to pause, and I want you to try this one by itself, and then press play and come back. All right, this one works out. You should get that alone. It's going to take Matt 15 hours to clean the house. So I think Matt and Jody should work together. Must be a dirty house. Okay, so that is today, solving in word problems. The next time we're together, we are going to graph, and I will give you your review for your test, and then Friday we are going to test. So work on the worksheet. You have the front of it is solving. I think there's 8 questions, and then I believe the back there's 4 word problems. So work on that and turn it in, and I'll see you next time. Bye.